Okay, so today we're doing another trigonometric identity. We're going to be looking at the complementary angles. Okay, so our learning intention is the knowledge of complementary angles and the skill in using these to solve problems. We'll be successful if we correctly identify complementary angles and if we can correctly solve problems using this understanding. In mathematics, the word complementary means there are angles that add up to 90 degrees, or if we're in radians, it's going to be pi over 2. Okay. So, firstly, here we have a triangle. We have a triangle ABC, and I've listed the opposite sides. So that's A, opposite C, and B. Okay. If I have a dedicated angle, theta, well, this opposite angle is going to be 90 minus theta because it's a right angle triangle. So if this was 20, that would have to be 70 in order for it to be a triangle. Yeah. So therefore, this angle here is 90 minus whatever this angle is. Okay. So if I wanted to find out what sine theta is, well, that's A over C, opposite over hypotenuse. If I wanted cos theta, that's adjacent over hypotenuse, so B over C. If I wanted tan theta, that's opposite over adjacent, that's A over B. Okay. If I now look at this angle, if I want sine of this angle, that's going to be B over C. My cos is A over C, and my tan is B over A. Okay. Note that when sine theta was A over C, that's the same as this cos 90 minus theta. This solution was the same as this solution. And cos theta, so the cos of this was B over C, well, that's the same as the sine of this one, B over C. So these match. So therefore, sine theta equals cos 90 minus theta, and cos theta equals sine 90 minus theta. And the same thing happens if we do the reciprocal. So cosec of this angle is hypotenuse over opposite, so C over A. The sec of this angle is the hypotenuse over the adjacent, C over B, and the cot is the B over A. And similarly, for this one, the cosec is C over A, or C over B, the sec is C over A, and the cot is A over B. Note that these match up. So cosec theta is the same as sec 90 minus theta, and sec theta is the same as cosec 90 minus theta. Note with your tans, tan of theta, this was AB, is the same as cot 90 minus theta. And tan 90 minus theta is the same as cot theta. Yeah? And these are in itself are reciprocals. Okay. Let's use this understanding to solve problems. Okay. Say I've just written up those relationships up here at the top. Say, for example, we have cos 50 minus sine 50. We want to simplify this. The problem is that we have a cos function here and we have a sine function here. And what we really need to have is all functions in the same method. So we can either change it all into sine or all into cos. If we changed this into sine, well, cos 50 or cos theta is the same as sine 90 minus theta. So that's the same as writing as sine 90 minus 50. Yeah? Because theta in this case would be 50. So this works out to be sine 40. Sine 40 take away sine 40 is just 1. Oh, it's just 0. Yeah? Okay. Let's do the next one. We want to find the value of z if sec is 3z plus 20, and that's equal to cosec 25. So the first thing I need to do is I need to change this so that they're all in the same function. And what I'm going to choose, I'm going to change this so it's cosec. So I'm going to write this as cosec 90 minus 3z plus 20. Well, that's the same as cosec 25. I hadn't changed that, I haven't touched it, so just keep writing it. Collect like terms, so 90 take away 20 is 70 minus 3z. Now that they're in the same methods, that means that this stuff here has to equal this stuff. So all I can write is 70 minus 3z equals 25. And now it becomes an algebraic expression we can solve for z. Minus 70 from both sides, we get negative 45. And then divide by negative 3, we get 15. So z is worth 15. Okay. We want to find the value of x if sec 11 pi over 36 equals cosec 2 pi x minus 36. So here we are in radians. All of a sudden we're in radians. The method doesn't change. We want to change this so that we have it both in sec or cosec. So what I'm going to do is I'm going to change this into sec form. So that's the same as writing it as, maybe I'll do this one. Okay. That's the same as writing sec. Before we were writing 90 minus whatever that was. Well, 90 in radians is pi over 2. So we go pi over 2 minus whatever this is. Okay? So now we're both in sec mode. I'm just going to take this, and that equals whatever this is. So 11 over pi equals 36. Well, that's the same as pi over 2 minus 2 pi x plus 1 over 36. Collecting all of this to be over 36, we get 18 pi minus 72 pi x plus 1. So multiplying this by 18, because 2 times 18 is 36. Multiply 2 by 36, and we get that. Cross multiply, we get this. Taking this value to the other side and bringing this value over to this side, we get the following. And now I'm just going to divide by 2,592 and to have x as a subject. We get that. And now we can simplify this to be 7 pi plus 1 over 72 pi, and that's the solution. Okay, thank you.